Hey y'all, I've been noticing this concerning trend in software development recently, and that's moving important features that are core to your app into third-party dependencies. As an example of this, I'm going to talk about Auth in this video. Many different companies are offering authentication as a service now. And those are companies like Auth0, like Clerk, even Firebase has a product for this now. Yeah, authentication is important and it sometimes can be a hassle, but it's actually a lot easier than it sounds. In this video, I'm going to show you how to roll your own auth in less than 15 minutes, relying only on standard cryptography functions. That will be the only dependency you're going to need for this project. The code samples today are going to be in Go and Postgres, but you could easily swap out either of those tools for whatever you're using currently. I want to start by showing you a quick demo of how this project works. So we're here in PAW, which is the software I use to make HTTP requests. We're hitting our local host on port 3000. So we're going to start by creating an account with this test information, and we're going to get a message back. Account created, now please verify. This means that if I try and log in before I verify my email, I'm going to get an error. So I'll show you by signing in with this now. And you're going to see user has not activated their account. So what I'm going to do is I'm going to verify the account by pulling in some of the secret data, which you would receive in your inbox. And I get this activation message. Now if I try and log in, I get a secure token that I can then pass to this who am I function. And that lets me pull in my user. So that's basic authentication functionality. I'm going to show you how you can build your own right now. Let's start by looking at the database schema. It's actually very straightforward. Here's our create table statements. We have our users table. We're going to have an ID, which is a primary key, an email, a password hash. It's important to note we're never going to store the user's actual password, just a secured mathematical derivation of that. We are going to save the date the user was created and whether they've verified or activated their account. And this is our tokens table, which is going to contain some secure random value that we can use to associate with a user. If someone has this value, we can assume that they successfully authenticated, and we can trust that because it's so long and so random, there's no way someone would have guessed that. So that's our schema. Let's go and look at our Go code. Okay, so this is our model. You see I've basically just modeled what the database schema is, but in our Go code, so we can query for it and we can scan data out, meaning that when we pull in a bunch of users, we can work with it as a Go struct instead of just using raw SQL. So now let's go to our main.go. I am using my own HTTP library called Pilot. I like it because it allows me to spin up routes quickly and handle stuff like database and different methods in a way that I find works well for me. But you can do this with any HTTP library in any language. So in this register route, we are going to read what the user has provided, which is an email and a password. We're going to verify that the user's information is correct and valid. This line here is super important. We're using a library called bcrypt, which takes some bytes as input and produces bytes as output. With the output bytes, we can verify that the input bytes are the same bytes that were used to make the output. And that's going to be important later because with the output bytes, you can never get the input, but with the input, you can always get the output. That's called a one-way function. I'll leave a link to a description of that in Wikipedia in the video description. You should check it out if you're interested. But you can assume that it's a secure derivation of a user's password. So we're going to store that into the database. After we've inserted the user, we're also going to insert the token. And like I mentioned earlier, a token is just a random long string. And then we would email this to the user. For sake of simplicity, I will just pull it from the database, but it's very simple to send an email. And that email would contain this token embedded into a link so that the user can click on it to verify that they control the email that they've submitted. Let's look at the sign-in route. We, once again, collect the data that the user will provide to us, which is an email and a password. We are going to look up the user where the emails match. And note, we're not going to do any password checking yet. We just want to pull in a user with that email. And we'll scan in the user so we can work with it in Go structs. Note that this error message here, user not found or invalid password, seems like it's not helpful because we're not really saying which one it is. But that's intentional because we don't want anyone to be able to just upload a bunch of emails to our service to check to see if they have an account. That's leaking information, and we do not want to do that. And you're going to see here that until we know that the user's password is correct, we're not going to reveal any information about whether that account exists or not. Here, we're going to run the bcrypt compare hash and password. And like I was mentioning earlier, we're just going to compare those input bytes and see if the same input bytes were made to create the output bytes when we registered the account. So while the server does receive the plain text password, it's not storing it. So that's the only way we can compare to check if the password is correct. Once we've reached this point, we can now reveal information about the user's account because we've verified that the hashes match, so we can reveal information. So here we'll check if the user is activated, and if they're not, we can actually give them a helpful message because we know they're them. If they have activated, then they're all good to log in. So we're going to make a token, save that token, and return that token to the user so they can send it in further requests. Let's talk about the verify endpoint real quick. We're going to get the string that they've provided as a query param. You could store that however you want. I'm just doing it as a query string here. We'll try and find that token where that value is what they've provided. If not, we'll just say could not verify. Again, we want to keep it vague to obscure information. Once we get that token, we know that that token belongs to the user. So what we can do is we can just mark that activated here where the ID is that token's user ID. And again, it's all secure because we know that the token is hard to guess, and we know from our database that we can trust that the token is linked to that user. So there's no way a user could use a token to activate a different account. It has to be their account because that comes from the database. And that's basically that route. So then this kind of test route here, who am I, is helpful for basically just testing that everything worked. So we are going to, again, pull the token parameter out of the query string. We're going to look up the token, and if there's no token, we'll say we can verify it. Then we will pull the user for that token, and we're just going to return that user, which is bad practice. We should not be returning a full user record, which is going to have their hashed password and probably some other information that we don't want to leak even to the own user. You just don't want that leaving your network. But as a test, it helps us show that, hey, everything's working like we expect. So that's how to build your own auth. As you can see, it's not really that complicated, and it's really not worth paying for. You could easily add additional authentication methods on top of this, like Google Auth, GitHub Auth, two-factor authentication. All of these things work on top of the system that we've already built. In addition, we know that our system doesn't depend on any third-party libraries or services. So if we were using an authentication service and they had an outage, that would bring our service down because no one could log into our service. But when it's baked into our service, it doesn't matter at all because if the service is up, auth is up. It also, of course, reduces the bill. At the end of the month, it's nice not to be paying however much a month to bring users onto your service. And of course, there's the privacy and security benefits of having your own system. You're not sending users email and password data to another company. It's all on your servers. I hope you enjoyed this video. I sure had a lot of fun making it. I'll be including a link to the source code in the description so you can run it, test it yourself, play around with it. If you enjoyed this video, please leave a like and a comment. It does really help, and I'll be reading the comments and responding. Until next time, happy coding.